Hello everybody and welcome back. We're taking a look at question number 16 on the 2002 Grade 8 Gauss competition. That's the multiple choice Grade 8 level competition. And question 16 says, 3 pennies are flipped. What is the probability that they all land with heads up? Okay. So there's a couple ways you can do this question, depending on your knowledge of probability. Okay. Now the quick, easy way of doing it is saying, well, there are 3 pennies. They don't really interact with each other, so these are sort of independent flips almost. How many pennies do we have? Well, we've got 3 pennies, and we want heads for each of them. Well, what's the probability of a single penny getting heads? 1/2. So a single penny will give heads half the time. We've got 3 of them. We want 3 heads, so 1/2 to the power of 3. That's going to be 1 to the 3 over 2 to the 3. That's 1 over 8, and I think that was A. Yeah, it's answer A. So that's the really quick way of doing it if you understand this, if you've done probabilities, if you've done flipping coins before. That's the quick way of doing it. But suppose we just understood the concept of probability. Right? Probability is usually the number of desired outcomes versus the total number of outcomes, or divided by the total number of outcomes. Okay? So if we wanted to work out the probability just based on this sort of definition, we would want to figure out the number of ways we can get all 3 heads, because that's the desired outcome, and then figure out the total number of outcomes we could have when we flip these coins. Okay, so let's make a little chart here. So we have our first coin, our second coin, and our third coin. Okay? So, what could we have? Well, we could have each of the coins flip up heads. That's certainly possible. Heads, 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 and that's our desired outcome. Or we could have heads, heads, tails. And we can start to make a little list of all the possible outcomes. And you should try and approach this in a very methodical way. What I'm doing is I'm letting the third coin be heads and then tails, heads and then tails, heads and then tails. I'm only changing the second coin when the third coin comes back to heads. And I'm only changing the third coin when both the second and third coins need to come back to heads. Okay? Very methodical way. This will get you all of them, even if you had a fourth coin. Just let the fourth coin do the HT stuff. Change the third coin only when the fourth coin turns heads. Change the second coin when the third coin returns to heads, that sort of thing. And this will get you all 8 possibilities. There are 2 outcomes, heads or tails, and we've got 3 different coins. That should give us 8 outcomes. If we had 5 coins, we'd be looking at 2 to the 5 outcomes. 2 outcomes, heads or tails, 5 coins, 2 to the power of 532 outcomes. So, we check our chart. It does have 8 different outcomes, so we do have them all. Incidentally, if you were, say, rolling 2 dice, there are 6 outcomes on each side of the dice. 2 dice, you'd expect 6 to the power of 2 different ways for the top of the dice to the numbers for on the top of the dice to be. Okay, so remember, probability is the desired outcomes over the total outcomes. Well, we know the total outcomes is going to be 8. We've exhausted our list, and if we thought about it, we should be getting 8 anyway. So how many have the desired outcome? Well, the desired outcome is all heads. And looking back in our chart, we only count that happens once. So we get ourselves a fraction, and we don't need to simplify it anymore. It's already in its lowest terms, 1/8. And that's an answer of A. So whether or not you did it the quick way or you needed to remember how probability works, That's two different ways we can do question number 16. So join me in the next video as we take a look at question number 17 on the very same contest.